Sorry, let me. So what I was saying is, I'm trying to figure out the maximum of this one, right? And what did I say to you? You increased the amplitude and you increased it, like not yeah, you you multiplied by two, right? Because here you moved from one to two, but then after that you now shifted the graph one unit down. This graph, you shifted this graph, you've shifted it one unit down. So what's gonna happen when you shift the graph one unit down? Do the maximum values remain where they are, where they were, or the minimum, do they remain where they were?
No, sir.
Right? Yeah. If I shift a graph vertically up or down, do the maximum values change or do they not change?
They change.
They change. So now what's gonna be the
They change.
maximum value for this graph?
One.
One. Gonna be one because it's the maximum value of the graph that we had, and then we minused one from, then you got one. Right? It's like now if in case I give you the graph of sine x plus 1, right? The first thing that you should ask is what is the minimum or the maximum of this? What is the max? It's 1, right? The max of sine x, it's 1, right? So now therefore the max of sine x plus 1 is gonna be what? 1 plus 1, because I'm shifting the whole graph by one unit up, right? But what is gonna be the min? The minimum is now gonna be what? The min is gonna be -1 plus 1. Because remember the mean of or the minimum of the basic sine function is -1. Then we add a 1 to it, it's gonna give us a 0. So therefore, the graph of sine x plus 1, it ranges between uh 0 and 1, 0 and 2. Right? So it will be starting here at 1, it will go up 1 unit, come down 10, and then go back because it's supposed to have that shape. Right? That's how this graph will look. You guys understand what I mean? How the vertical shifting affects the minimum or the maximum?
Yes, sir. Yes.
Okay. So yeah, that's so now we figured out the maximum. Let's figure out the minimum. So the minimum was how much for the volt was -2, right? We now have to minus what? 1. It's gonna give us how much? -3. Am I right or wrong?
You're right,
Correct,
sir.
sir.
You're right, sir.
Okay. So fine, once we figure those things out, then it's much easier to sketch the graph. And remember, we want to sketch this graph in this domain, 0 degrees to 360. Okay, let me now put the lines for me to draw. The first and foremost thing that you must remember is how we move in the domain of sine. We always move by multiples of 90. So it will be 90, 180, 270, 360, right? But then now what is the maximum? It's 1. So if in case I have a value of 1 there, so the maximum, this is my maximum. My minimum has to be -3. So there is my minimum, right? Okay. So the first and foremost thing that you must be able to identify is, okay, for the original sine x function, for the original one, think about it. The original one looked like this. It used to use this as like this line here. It used to use it as a cross reference to say, oh, I'm going up, down, and then up again, right? So this line here, this one that I'm gonna color in red, it's very important. You see that line? That line has an equation of y is equal to 0, right? So when the graph shifts, it's also gonna shift with it. Because that's now we're gonna use that as where to start the graph and where to end the graph. Because you see the graph starts on that line and ends on that line, and it cuts that line. You guys see that? So now we've shifted this graph 1 unit down, right? We've shifted it 1 unit down. So therefore, we must also take that, we must try to, so therefore, here's the line y is equal to 0. When we shift it down, we're going to get y is equal to -1. So we have -1 there. We can have a bit of dashes there to negate that -1. And then now that's where we're going to start our function. Then it's going to go up. Now let's start. We know that we are going to start at 0 degrees. It's going to give us 0. Then we're going to go to 90. 90 is going to give us that 1. Then we're going to go to 180. 180 is going to give us how much? I think -1, right? 180 must, you can plug these into your calculator. 270 must give you -3. Then 360 must give you -1. Guys, am I correct? Plug these values into your calculator. I tell you have the
Say
equation.
the, the zero, sir.
What's
It's the equation. The equation is 2 sine x minus 1, right, sir?
yes.
Yeah, so when you plug in 0, say it gives us -1.
Yes, and I started at -1. That's why I started here.
Oh, I thought you said 0 will give us 0, sir. So,
But I started at -1. Do not, most of the time, don't mind what I say. Look at what I write. So now let us join. Do you see that now? That's how your graph must look. You see how we thought so much, so hard about where which point, and we ended up had to think about this line here. This line was called -1, which is a bit of a large amount of work. Whereas you can just use a calculator to get the points. Let me teach you how to use the calculator. Does everyone have their Casio calculator near them?
Yes, sir.
Yes, sir.
Yes, sir. Sir.
Okay. Press mode. Then you see option 3 that says table.
Yes, sir.
Press it. It's gonna give you f at x. It doesn't matter. It does not matter whether your graph is here or x, it's y, h, you always gonna use f, right? For the function that you want to draw. So what is the function that we want to draw? 2, right? And then you type 2 and then press the button of sine. You have 2 sine open bracket.
Yes, sir.
Then after that, now you want the letter x, right? So that's when you press alpha and then press X there. I think there's an X there when with the closing brackets button.
Yes, sir.
You press it, so now you have an X in your calculator.
Yes, sir.
Now close that bracket of X. Close it. So that X is inside two brackets. Have you closed it?
Yes, sir.
Then now press minus 1. Does the equation look exactly like what you are being asked?
Yes, sir.
Then now press equal sign. Then now it's saying here at X, right?
Yes, sir.
Because you're only drawing one function, ignore. Then say press another equal sign. Then you are saying you see now it's saying start. By start, it's asking you which degree to start at. Do you want to start at 1 degree or at 0 degrees?
0.
So
Zero.
type 0. Say 0 now and then equal sign. You are seeing now it's asking you end and it's written 5 there.
Yes, sir.
So you must type 360 and then press equal sign. Yeah, it's now asking you step, but it's
Yes, sir.
saying 1. Okay, remember when we were talking, what did we say the step must be? It must always be 90 degrees for the basic functions, right?
Yes, sir.
So it's 90 right now. You press 90, you type 90 and then say equal sign. It's giving you all the points there. You want me to use those
Yes,
points
sir.
and show you? Let's now. You have points. You have 0, it corresponds to -1. You have 90, it corresponds to 1. You have 180, it corresponds to -1. You have 270, it corresponds to -3. You have 360, it corresponds to -1. Right?
Yes, sir.
Okay. So now let's draw now. Gonna be simpler. Check. There it is, I guess. Then you have a 0 and 90. Let's say 180, 270, 360. I get. Then you see what you must have a 1, you must have a -1 and a -3. I get. Then now let's start. For zero, you must have the point -1 I get. So I come here. I have a -1. For 90, I must have 90 must correspond to 1. I come there. Then I go to 180, it corresponds to -1. I do a point there, that means. Then I go to 270, it corresponds to -3. I go there. Then I go to 360, it says -1. I go there. Then I connect now. I just connect all my points. You see? Is it easier to do it this way?
Yes, sir.
Mhm.
Yes, sir.
Yes. So that's a shortcut that we can use. And an examiner can actually ask you to find, if in case an examiner were to label this as point A, where the graph cuts the x-axis, and say, give us the coordinates of A. You know already that A is a certain x value and 0, right? So you must just solve for the x value. You already know that the y value is 0. So that means you must say, okay, remember that you have the graph f at x is equals to 2 sine x minus 1. You already know that y is 0, right? You want to solve for x, right? Then so you're going to end up having sine x equal to 1/2, right? then you know that you are looking for an angle in the first quadrant. Remember, it's an angle in the first quadrant because it's found, this A is found between 0 and 90. So you can just use reference angle. So that x value will be the reference angle. So it will be just equal to sine inverse of 1 over 2, which is just 30 degrees. So therefore, A, the coordinates of A will be 30 degrees, 0. Do you see? This now
Yes.
forms part of you. But then what if it was a point? It was a point here. So now, because you know A, you can now find the coordinates of a B, if in case I give you a B there. It's an X and it's still a 0 again. So here's an X at B. Because now, remember, where is B? B is in the second quadrant, right? So that means when you are here, remember that it's a general solution once you are here. It's a general solution. So you've got this 30 degrees is an angle in the first quadrant. And then it's also again a reference angle. You are solving for an angle in the second quadrant. How do you find the general solution for an angle in the second quadrant? That angle is always, so B is going to just be 180 degrees minus the reference angle. So it's going to be minus 30, 0. So B is what? Is 150 degrees, 0. Do you see that? You must still remember your cast diagram. Here it's always 180 minus in the second quadrant. Here it's theta. Trigonometry links, guys. The things that I told you in first term, you must always still know. You guys understand what I just did?
Yes, sir.
Because
Yes,
remember
sir.
that you can divide your Cartesian plane into quadrants. This is quadrant 1. Then 90 to 180 is quadrant 2. 180 to 270 is quadrant 3. And in quadrant 3, you do see that your graph now starts to become what? Negative. Starts to become negative. Negative. But then in the two quadrants, your graph was what? Was positive. From quadrant 1 up until quadrant 2, your graph was still relatively positive, I'd say. No, man, I mean the original function. Sorry. Even in case you look at this graph, so what my interpretation must relate to the original functions. Check. This is quadrant 1. This is quadrant 2. This is 1. This is 2. This is 3. This is 4. So you see from quadrant 1 up and quadrant 2, sign is what? Is positive. Then when it gets to quadrant 3, it becomes what? Negative. And that relates to cast diagram. It's only positive in quadrant 1 and quadrant 2, negative in quadrant 3 and quadrant 4. Same goes for cosine. It's positive in quadrant 1 and only positive in quadrant 4. Hence, it's only positive there and it's only positive there. But quadrant 2 and quadrant 3, it's under the x-axis. It's negative, the graph. You see that? Tangent function is always positive in the first quadrant, but then it's negative in the second quadrant. And then it's positive in the third quadrant. Remember that here it's the third quadrant. It's positive. And again, it's negative in the fourth quadrant. You see, it's negative here. It's negative. So cast diagram is even in your functions. You must think about it. Right? So guys, for
Sir?
tonight,
Yes, so I have a question. How did you get sine x is equals to 1 over 2? I didn't really understand how
it's
you got
just your
that.
algebra there. Remember here you have 2 sine x equal to minus 1 is equals to 0. That's your algebra. That's you and your algebra. Because if in case I have 0 is equals to 2 sine x minus 1. What will be sine x then? I transpose 1 and divide by 2.
Okay, thank you, sir.
So remember, algebra is also very important. Simplification. And simplification involves a lot of things, identifying like terms, factorization, stuff like those. Please, 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 if in case you are not familiar with those skills, revise them. Okay? So for tonight, I'll stop the recording here.